types, variables, and arithmetic. Every name and every expression has a type that determines the operations that may be performed on it. For example, the declaration int specifies that int is of type int. That is, int is an integer variable. A declaration is a statement that introduces a name into the program. It specifies a type for the named entity. A type defines a set of possible values and a set of operations for an object. An object is some memory that holds a value of some type. A value is a set of bits interpreted according to a type. A variable is a named object. C++ offers a variety of fundamental types. For example, bool, boolean, possible values are true and false. Char, character, for example, A, Z, and 9. Int integer, for example, 1, 42, and 1066. Double precision floating point number, for example, 3.14 and 299,793.0. Each fundamental type corresponds directly to hardware facilities and has a fixed size that determines the range of values that can be stored in it. A char variable is of the natural size to hold a character on a given machine, typically an 8-bit byte, and the sizes of other types are quoted in multiples of the size of a char. The size of a type is implementation defined, that is, it can vary among different machines, and can be attained by the size of operator. For example, size of char equals 1 and size of int is often 4. The arithmetic operators can be used for appropriate combinations of these types. X plus y plus x, unary plus x minus y minus x, unary minus x multiply y multiply x divide y divide x% y remainder modulus for integers. So can the comparison operators x equal y equal x not equal y not equal x less than y less than x greater than y greater than x less than or equal y less than or equal x greater than or equal y greater than or equal. In assignments and in arithmetic operations, C++ performs all meaningful conversions between the basic types so that they can be mixed freely. Void sum function that doesn't return a value. Curly braces D equals 2.2. Initialize floating point number. Int I equals 7. Initialize integer. D equals t plus I. Assign sum to D. I equals d times I. Assign product to I truncating the D times I to n. Note that equals is the assignment operator, and equals tests equality. C++ offers a variety of notations for expressing initialization, such as the equals used above, and the universal form based on curly brace delimited initializer lists. D1 equals 2.3. D2 curly brace 2.3 curly brace. Complex Z equals 1. A complex number with double precision floating point scalars. Complex Z2 D1, D2. Complex Z3 equals 1, 2. The equals is optional with curly braces. Vector int v1, 2, 3, 4, 5, 6. A vector of ends. Int I1 equals 7.2. I1 becomes 7. Int I2 7.2. Error. Floating point to integer conversion. Int I3 equals 7.2. Error. Floating point to integer conversion. The equals is redundant. A constant cannot be left uninitialized, and a variable should only be left uninitialized in extremely rare circumstances. Don't introduce a name until you have a suitable value for it. User-defined types, such as string, vector, matrix, motor controller, and/or courier, can be defined to be implicitly initialized. When defining a variable, you don't actually need to state its type explicitly when it can be deduced from the initializer. Auto b equals true. A bool. Auto ch equals x. A char Auto I equals 123. An int. Auto D equals 1.2. A double. Auto Z equals sqrt, y. Z has the type of whatever sqrt, y, returns. With auto, we use the equal syntax because there is no type conversion involved that might cause problems. We use auto where we don't have a specific reason to mention the type explicitly. Specific reasons include: the definition is in a large scope where we want to make the type clearly visible to readers of our code. We want to be explicit about a variable's range or precision, for example double rather than float. Using auto, we avoid redundancy and writing long type names. This is especially important in generic programming where the exact type of an object can be hard for the programmer to know, and the type names can be quite long. In addition to the conventional arithmetic and logical operators, C++ offers more specific operations for modifying a variable. X plus equals y. X equals x plus y. Plus x. Increment, x equals x plus 1. X minus equals y. X equals x minus y. Minus x. Decrement, x equals x minus 1. X times equals y. Scaling, x equals x times y. X divide equals y. Scaling, x equals x divide y. X% equals y. X equals x% y. These operators are concise, convenient, and very frequently used. Thank you for watching.